Hello and welcome to Tech Leo. Today in this video I will be talking about how to do data analytics on BigQuery table data using Python with the help of a library called Polars. So Polars is a very new library which resembles with Pandas, but it has its own advantage, such as it is faster than Pandas to load and to process the data, especially when you have a huge data with millions of rows. It is easy to use. There are many functions which resembles to SQL query. They will look okay, we will look into that later in the video as well. It is an open source library. You can install it directly using pip and you can contribute to it as well from the GitHub repo. So for this video we will be using BigQuery and Vertex AI APIs. Let's dive into it. So first I will open my browser and go to GCP, and I will make sure that I have BigQuery and Vertex AI, both of them. So first I will go to here. And also for the sake of this video I have created a new project, that is YouTube. So let's go switch to YouTube. Yes, so as you can see that I have the BigQuery enabled. So if you have, you can also check, and if it is not enabled you can enable the API. So once this is confirmed, then I will again go to GCP main page, and here I will search for Vertex AI. And here also I can see that the Vertex AI API is enabled for me. So I will just go down to Workbench and check if I'm able to access the Workbench as well, because we are going to create a Jupyter notebook from this Workbench. Okay, so I can access this. I have the access to create as well, create a new Workbench. So before creating a Jupyter notebook, I will be first creating a service account for this, which will be able to access BigQuery data from Vertex AI Jupyter notebook. So let's go to the main page, then I will go to IAM and admin, and then service accounts, and here I will be creating a new service account, and let's give it a name, Polars Python service account. Okay, and then click create and continue. And for the role part I will search for BigQuery. Yeah, so there are a lot of roles. I can either give the role of BigQuery data viewer, where it can um, extract the data from BigQuery, but it will not be able to export the data back to BigQuery from Jupyter Notebook. So you have to be specific which role you have to select. So as of now, I will be selecting BigQuery admin, but there are other roles as well which you can select to work with BigQuery data. So then I will click on continue, and that's it. I'll click on done. So as you can see that the service account is created now, it is showing here. So now I will go back to my Vertex AI, and here I will create a new workbench. I'll click on advanced options. Yeah, so here the instance name will be something similar, Polars Python instance. I'll keep the region and zone default, and then I'll click on continue. Operating system will be Debian 11, and here I can keep it as Python 3, but then TensorFlow will come with pre-installed libraries, so let's keep it as Python 3 only. CUDA 11.8, and then click on continue, and then the machines I will also keep it default. Maybe I'll increase the memory just a bit to 64 GB of memory, and then click on continue. Okay, just a second. Idle shutdown inactivity of 30 minutes. Click on continue, I will keep the other things default. Continue, continue. Okay, create. And let's wait for it to create. Okay, it took a couple of minutes to actually create the whole instance, and also in between I got an error. That is, since I'm using the free tier accounts, I won't be able to get 64 GB of RAM. I only got 16 GB of RAM, so I switched back to 16 GB and created another instance. So as you can see that the instance is ready now, it is active, and I can click on open Jupyter Lab. It will open a Jupyter notebook for me. And also as you can see that I have created the Jupyter instance inside user managed notebooks. You can create it on instances as well, because I can see that the user managed notebooks is going to be decommissioned, or is going to be able to, you have to upgrade it once a particular time has been exceeded. So you can go back to instances, and here you can create another one. But since I have created it already, I won't be creating another one right now. So I will go to the Jupyter Lab, and I like to keep it dark, so I will keep everything dark. Yeah. So here, my two I have two tasks to do. First of all, I have to install the polars. So I will click on a terminal, and here I will just type pip install polars to install the polars library. Yeah. Once polars is installed, and next I will install Google Cloud BigQuery library. Pip install. Yeah, done. And then I will install Google Cloud BigQuery storage. This is another library. Done. Then I will install pip install clear, pip install python date util. This is also done. Then I will install pip install pyarrow. Yeah. So once all of this is done, I will also include a requirement.txt file in a BigQuery repo that I have created for specifically for this video. So there I will include all these libraries, so you don't have to specifically type every library and install them. You can install the whole requirement.txt file. So I'll be providing that one as well, and I will give you the repo link in the description as well. So these are all the libraries I want which are required to install to work on the polars library. So once all these libraries are installed, my next task will be to create a dataset in BigQuery. So let's jump into that. Okay, so with the help of ChatGPT, I tried to create a SQL query. Just a second, I will show you. I have created a repository, and this is the requirement.txt that I was talking about. That from here you can run a code, command line code, that is pip install requirements r requirements.txt, which will install all the required libraries. And coming back to creating a data set, I have created an SQL script here, which basically creates a table that is students, and this is the schema of the table. So it has a student ID, then a first name, then the last name, then date of birth, and gender, grade level, and email, phone number, address, enrollment date, and GPA. And this is the SQL query which will fill this table randomly with random data up to 1 million rows. So I have already run this code, SQL query in BigQuery, and I will show you. what is the final output. Just a second. Yes. So I have created a dummy sets called dataset, and there I have created the student table. So as you can see that this is the table, and when I click on preview, I can see that it has 1 million of rows, and it has a random data which has been generated using this SQL script. So you can just go to the BigQuery and copy this whole code and paste it over here, and you have to give your project ID. For example, this is the project ID that I am working on, so I can give this. I can give the dataset ID, the dataset that I have created, that is dummy sets. And here, since I have already created the table, I will be creating students underscore one, and I will run this, and let's see. Okay, yeah, so I have to update this line as well. So I will just copy this whole thing and paste it over here. And then hit on run. Okay, I think I have to just run the below code, because the first query is already completed, the second query was stuck. So I will just run this. I will click on run, and now let's wait for the table to create. Okay, so the table is done. It is created, and it is showing as this statement added 1 million of rows to student underscore one. So I click on go table and see. Yeah, it is visible, and it has a 1 million of rows, and you can see that this is somewhat similar to the students table that I have created earlier. So this is how I have created a dummy dataset to work on. And now, since we are ready with the dataset, now our next task will be to import this BigQuery data into Vertex AI notebook. So let's jump into that. So first I will go to GCP, and then I will first of all change the project name to YouTube. That is where I have created the Vertex AI Jupyter notebook, and here I will search for workbench. Yeah, this one. And there I hope I will see the instance that I have created. Yes, this one. So I will first start this, and it will take a couple of minutes to start. So let's wait. Okay, as you can see that the instance is started now. But while the instance was getting started, I saw one issue. So as you can see that the owner is some other service account and not the service account that we have created in the beginning of the video. So to change the service account, I will click on compute engine and then VM instances. In here I will try to change the service account, because if I keep the default one, it won't be able to access the BigQuery data. So I click on the name, then I click on edit. Yeah, let's scroll down. Okay, I have to stop the instance first. Okay, I paused the video recording and stopped this instance, and let's scroll down, and now I can change the service account. Yeah, this one. Click on the new service account that we have created on the starting of the video, and then click on save. Now once I have updated the service account, I will go back to the workbench, and I will start this again now. First of all, I will reload just to make sure that the changes are occurring here as well. Yeah, now the new service account is showing up here. Now I will start this instance and wait for it to start, and then I will open the Jupyter lab. So the instance is started now. I will click on open Jupyter lab to let the Jupyter notebook open. Yes, so now I will create a new Jupyter notebook and let's name it as polars analysis. Yeah, and first I will make sure that polars is installed. Yeah, so as you can see that the cell was executed, so it's basically a proof that polars was installed correctly. Okay, so once this is confirmed that polars is installed, now I will be importing some libraries. One of them is BigQuery from Google Cloud, and then I will try to authenticate the client by using BigQuery.client function and then hit run. So once this is done, then I will try to import the table from the BigQuery. So we have created the students one. So I will try to import this one only. I will click on query on new tab, and then I will import the whole table. We don't need limit now. So I will just copy this, and in polars you can use py arrow, which is a function from there you can import this whole big data directly using the SQL query. So I will show you how you can do that. For that, first of all, you have to create a variable student1. I will create something similar like that, and then from polars has a function called from arrow, which is basically uh, first of all it tries to convert the BigQuery data to arrow, and then it will extract the data from using from arrow. I will show you how. So it is client.query, and here inside this we will be putting our query, and outside this we will write to arrow. Yeah, so I hope this is self explainable. So it is basically converting the output of this query to arrow, and then it is reversing the process to convert it into a polars data frame. So inside this I will be putting the query that we have copied right now. So this is the query. Let's run this. So it will take some time because since it's a okay, it was fast enough. And then I will run this one, and you can see that this is the data that is being extracted from BigQuery, and it has 1 million of rows, and this is the data frame that we have. So yeah, it is basically converting the BigQuery table into a data frame, polars data frame. So this is a data frame. This is a polars data frame. Yep. So this is it. This is how you basically extract the BigQuery table from BigQuery to Jupyter Notebook, and you can work on this data frame as you wish. For example, I will check the row number by using student shape 0. Yeah, so this is 1 million of rows, and you can also check the describe function, which is somewhat similar to the pandas, and as you can see that it has described it in milliseconds. It didn't take any much time to understand the whole data set, so it took a very less time. Okay, so I did create another data frame, that is by using pandas, and then after importing the same table using pandas, I did some comparisons of polars versus pandas as well in the whole notebook. As you can see that sometimes the pandas was more faster than polars, and sometimes polars was more faster than pandas. So you can take a look. I will be uploading this same notebook in the GitHub as well, and I will share the GitHub repo link. You can have a look on this notebook. If you want to learn more about polars, you can learn from here, and then maybe you can learn from YouTube and their own documentations as well. So I'm not going to explain the whole stuff here because it will take a very long time to explain each and every line. So here, as you can see that here in this apply transformation, I'm creating a new column by giving all these conditions, and you can see that pandas took 17 seconds here, but polars took 0.03 seconds. So this is the difference in the performance. And similarly, I have given some SQL operations, like if you have some SQL queries and you want to do the similar stuff in polars, you can do them here. I mean, I have given the examples, so you can take a look as well. So for example, if I'm using group by, you can use the group by functions here in polars, and you have to give the aggregated functions as well. And if you're using join, you can use the join keyword. And if you're using any window functions, so windows are a bit more complicated, you can go through their documentation part and understand how it works. And we have having clause as well, so where you have to add another filter function in after aggregation. And if you have case statement, that is if else statements, so you can use when, then, and otherwise. So for example, if you have any if statement, you can use something like pl dot when, then, otherwise. So it's like when is equivalent to if, then is equivalent to elif, or if it is true, then this the condition will go move towards here, and if it is false or if it is else, then it will move towards here. So this is the basic syntax of polars if else condition. So once all of this is done, I'm thinking of exporting the table back to BigQuery. So for that, I think we have now 2 millions of rows. Let's see how many rows we have. Okay, so as you can see that here we are joining the tables data frames. One data frame has scores as well, and another data frame only has this is the original data frame, and this one has scores as well. So let's join this and make this a data frame of 2 million rows, and then we will try to export this back to BigQuery. So instead of inner, I'm using outer now, and let's run this. Okay, maybe I have to add a suffix as well. Yeah, so now I'm guessing that we have a data frame of, oh, it has 5 million. Okay, so we will be trying I will try to upload this back to BigQuery, and let's see how it works. Okay, so let's try to export this back to BigQuery. So first of all, I will try to change the name as well, maybe to df polars new or out, and then do something similar to here as well. And here, as you can see that I have, instead of using outer join, I'm using left join, because I have seen that it has a lesser number of rows as compared to 5 millions of rows. Okay, so once this is done, I will scroll down a bit, and now, so so there are many ways of storing the data frames, and one of them is Parquet files, that is Parquet files. So Parquet files is one of the way of storing your data. So here what we'll do is we will store the output data in a Parquet format, and then we will try to export this Parquet file to BigQuery. So for that I have to first of all save this data frame into a Parquet file. So for that I will write df polars out dot write. So write Parquet is a function in polars where you can write this polars into a Parquet file, and I will write give the name as student output dot Parquet. Let's see. Yeah, so once this is done, I think we have a Parquet file now. And we will try to export this Parquet file to the BigQuery. So for that, first of all, I have to give a job config. So this is a code. I will just copy this and paste it over here. So this is a job which we have to define to load the data into BigQuery. So this will tell you the format, that is we are using Parquet format, and this is the way how you should be writing the data, that is you have to write disposition, and if there is any table already present with any other schema, it can be truncate and we can write over that table. And once that is done, I will define the id of the table which we will be going to create, that is we the BigQuery, we have this project called solo yt dash youtube, and there we have this dataset called dummy sets. So I've defined the same stuff here, solo yt youtube dummy sets, and I have given the name of the table as well, that is student output. As you can see that we don't have student output yet here, so we'll be creating this new table, and I will be giving this table name to this line of code. So we are opening the Parquet file, and while opening we are giving the job, that is load table from file. So once we have opened the Parquet file, we will load this file into a table, and I am giving the path of the table here, and I'm giving the job configurations as well. So these are the job configurations, and this is the path that I have given, and this is the content, that is this one f. So all this stuff, when I give it and I wait for the job to done, that is job.result, and let's wait for it to upload now. Okay, so it took 10 to 20 seconds to upload. Now let's check if this particular table is reflected here as well. So for that, either we can refresh this. I don't see the refresh option, so I will just reload this. Yeah, and if I check the data set, yeah, so as you can see that the student output table is created, that is this on the same time 640, and now let's preview the table. Yeah, it has the same number of rows. So as you can see that this is how you can export your data frame back to BigQuery. So if you have a pipeline, if you have if you have a operation, or if you have a task where you have to do some operations on any table in BigQuery, you can't maybe you can do the operations using SQLs, but if you want to do the same operations using Python, you can, this is how you do it. You can just import the table into your any Jupyter notebook, do the calculations, do the operations, whatever you want to do, and then export it back to BigQuery, something like this. So this is how you use Polars library in data analysis. So as you can see that as you have saw that Polars is faster and it is easy to use, and you can do all the stuff which whatever SQL is doing, you can do the stuff in Polars as well, and it is comparatively faster than Pandas with bigger data. So this was just a encouragement video, or you can say um, overview video, like how better or how good this new library is, that is Polars. So I encourage you, I ask you to use this as well in your daily data analysis projects. You can try it out. You can also compare it by yourself, or you can refer this notebook as well. So I'll be uploading this notebook into GitHub. I will share the link as well. And that's it. Thank you so much for the video. Stay tuned. I have more videos coming up, and also let me know in the comment section how you like this video. See you. Bye.